Alright, in this video I'm going to give a little tutorial on how to simplify radicals. Okay, so if you have something inside a radical, again this symbol here I'm going to sort of highlight for you. So this is the radical, right? That thing, right? There's your radical. This is how you simplify things if the number inside is not a perfect square. So obviously if it was a perfect square like square root of 25, you could just say, well, that's 5. But since the number 50 in here is not a perfect square, you have to think about, okay, what is a perfect square that goes into 50, right? And you can try your calculator, look at a multiplication table, but you're going to think about your perfect squares like 4 or 9 or 16 or 25 or 36 or 49, etc., right? And thinking about, okay, which one of those goes into 25? And if you've been thinking about this, you know that, okay, well, I know that 25 goes into 50. That's like 25 times 2. This is going to help us simplify because once we have a perfect square, we can sort of pull that out of the radical, right? What I like to do first is sort of say, okay, well, I'm going to separate this. So one of the rules of radicals is that we can separate that out. We can make that square root of 25 times the square root of 2. And then since, again, we know that the square root of 25 is just 5, we can say that's like 5 root 2. And that is what I want. And if we can do this, it helps us do other types of problems that I'll show you in a moment. Again, just another little bit of practice. We'll think about our perfect squares like 4, 9, 16, 25, 36, etc. We'll think about, okay, which one of these numbers goes into 24? And it's that number 4 right there. So 4 goes into 24. We know that. So let's say, okay, that 24 is like 4 times 6. That means that's like root 4 times root 6. We know the square root of 4 is 2. That will give us an answer of 2 root 6. Alright, and once we're able to do that, that actually lets us simplify radical expressions in a new type of way. So, for example, if we were given a problem like this, 3 root 2 plus 2 root 50 plus 9 root 5. Actually, let's just say 9 root 6. Say 9 root 6. Okay? Well, we can simplify this problem because just like with x's and y's, with polynomials, you can only add radicals if they have the same exact thing inside the radical. So here in this first one, we have a 2 in the radical. The second one we have 50 in the radical, and this last one we have 6 in the radical. So it looks like right now we cannot simplify them. But I'm going to look at these numbers and I'm going to say, well, there is not a perfect square that goes into 6. There's not one that goes into 2, but there is one that goes into 50. So I'm going to try to simplify this and see then if we can combine any terms. So for example, we could say, okay, that would still be 3 root 2, it doesn't change. But we also know from a previous problem that root 50 is like 25 times 2. Everything else I'm just going to keep writing, stay the same. I'm going to put this in parentheses to highlight it for you. Okay, again, from there, we can, again, this stays the same so far. We'll separate those radicals like we have been doing. And we know here that root 25 is 5. So we can say that's like 3 root 2 plus 2 times 5 root 2 plus 9 root 6. And here we're just going to multiply. 2 times 5 is 10. So now we have 10 root 2's and 3 root 2's. And that gives us a total of 13 root 2's, just like if you were adding up something with an x. Since this is root 2 and that's root 6, you can't simplify root 6 anything. So we're left with just 13 root 2 plus 9 root 6. So now you can see how simplifying radicals can help us to solve more complex problems.